Section 517.160 of the National Electrical Code, or NEC, addresses isolated power systems. Specifically, 517.160 details where these systems are required. Isolated power systems shall be provided in the following locations: firstly, patient care areas; secondly, critical care areas; and thirdly, other critical areas designated by the authority having jurisdiction. Therefore, the presence of isolated power systems isn't solely a design practice but a mandate in specific healthcare settings according to the NEC. Patient care areas, critical care areas, and areas determined as critical by the authority having jurisdiction, or OJ, necessitate the installation of isolated power systems. 517.160b outlines additional requirements. These systems must adhere to Article 517 requirements concerning design, installation, maintenance, and testing. The isolated power system shall be designed and installed in accordance with the requirements of Article 517. The isolated power system shall be maintained in accordance with the requirements of Article 517, and the isolated power system shall be tested in accordance with the requirements of Article 517. Article 517 encompasses a broader set of guidelines for healthcare facilities. Therefore, understanding the entirety of Article 517 is vital for compliance. Let's delve deeper into what constitutes patient care areas, critical care areas, and the role of the authority having jurisdiction. Patient care areas generally refer to spaces where patients receive medical treatment or monitoring. These areas demand a high level of electrical safety to minimize the risk of electrical shock or other hazards to patients and medical personnel. Critical care areas are specialized locations within healthcare facilities where patients receive intensive medical care and are subject to continuous monitoring. Examples include intensive care units, cardiac care units, and operating rooms. The electrical systems in these areas must be exceptionally reliable and safe to support life-sustaining equipment and procedures. The authority having jurisdiction, or OJ, plays a crucial role in enforcing electrical codes and standards. The AHJ has the authority to designate other critical areas within a healthcare facility that require isolated power systems based on specific risk assessments and operational needs. This designation ensures that all areas where electrical safety is paramount are adequately protected. Now, let's discuss the purpose of isolated power systems. Isolated power systems are designed to prevent electrical shock hazards in patient care areas by isolating the electrical supply from ground. This isolation minimizes the flow of fault current through the patient's body in the event of a ground fault, thereby reducing the risk of electrical shock. The system typically includes an isolation transformer, a line isolation monitor, and grounding and bonding provisions. The isolation transformer creates a separate and grounded electrical system which prevents a single point of failure from causing a dangerous electrical shock. The line isolation monitor continuously monitors the impedance from each line of the isolated power system to ground. If the impedance falls below a certain threshold, indicating a potential ground fault, the monitor activates an alarm to alert medical personnel. Proper grounding and bonding are essential for maintaining the integrity of the isolated power system and preventing the buildup of static electricity. All conductive surfaces in the patient care area must be properly grounded and bonded to ensure a low impedance path for fault current. Moving on to the design considerations for isolated power systems, it is essential to select appropriate components and configurations to meet the specific requirements of the healthcare facility. Factors to consider include the size and type of isolation transformer, the sensitivity of the line isolation monitor, and the grounding and bonding methods. The isolation transformer must be sized to accommodate the anticipated load in the patient care area with sufficient capacity for future expansion. The line isolation monitor must be calibrated to provide adequate sensitivity without causing nuisance alarms. Grounding and bonding must be performed in accordance with the NEC and other applicable standards to ensure a safe and reliable electrical system. In terms of installation practices, isolated power systems must be installed by qualified electricians who are familiar with the NEC and other relevant codes and standards. The installation process should include thorough testing and inspection to verify that the system is functioning correctly. All wiring and connections must be properly insulated and protected to prevent accidental contact with conductive surfaces. The line isolation monitor must be installed in a readily accessible location for easy monitoring and maintenance. Grounding and bonding connections must be securely fastened and protected from corrosion. Regarding maintenance requirements, isolated power systems require regular maintenance to ensure their continued reliability and safety. Maintenance activity should include periodic testing of the line isolation monitor, inspection of grounding and bonding connections, and cleaning of electrical components. The line isolation monitor should be tested at least annually to verify that it is functioning correctly. Grounding and bonding connections should be inspected regularly for corrosion or damage and repaired or replaced as needed. The electrical components should be cleaned periodically to remove dust and debris, which can reduce their performance. Finally, let's discuss the testing procedures for isolated power systems. Testing is essential to verify that the system is functioning correctly and providing adequate protection against electrical shock hazards. Testing procedures should include insulation resistance testing, ground impedance testing, and line isolation monitor testing. Insulation resistance testing measures the resistance between the conductors of the isolated power system and ground. A low insulation resistance indicates a potential ground fault and requires further investigation. Ground impedance testing measures the impedance of the grounding and bonding system. A high ground impedance can increase the risk of electrical shock and should be corrected. Line isolation monitor testing verifies that the monitor is functioning correctly and will activate an alarm in the event of a ground fault. In summary, isolated power systems are critical for ensuring electrical safety in patient care areas, critical care areas, and other critical areas designated by the authority having jurisdiction within healthcare facilities. They work by isolating the electrical supply from ground, thereby minimizing the risk of electrical shock to patients and medical personnel. Compliance with NEC 517.160, along with proper design, installation, maintenance, and testing, is essential for maintaining a safe and reliable electrical system in these sensitive environments. Understanding the specific requirements for each type of area, whether it's a patient care area, a critical care area, or another area designated by the authority having jurisdiction, is crucial. The authority having jurisdiction plays a vital role in ensuring that all areas where electrical safety is paramount are adequately protected. Isolated power systems are not merely a design consideration, they are a mandated safety measure in specific healthcare settings.